So the equation mv prime equals f minus cv squared has led us to this equation where we have to evaluate this integral. We have evaluated the integral 1 over 1 minus AV times 1 plus AV, and this integral is identical to this one provided A is the square root of C over F. The result for the integral, we recall, was 1/2 natural log of 1 plus AV over 1 minus AV, so that the left-hand side of our integral becomes 1/2 the natural log of the absolute value of 1 plus the square root of C over F V divided by 1 minus the square root of C over F V. This will be the integral on the left-hand side. The integral on the right-hand side is just F over MT plus C. Now, again, we have an absolute value, which is not unusual when we do integration by parts. If we assume that square root of C over F V is less than 1, so let's see, write that pretty small so we can write the expression down here and then continue it. Assume that 1 minus the square root of C over F V is greater than 0. Now, if we solve that for V, that means that V is going to have to be greater than the square root of F over C. Now, the square root of F over C is going to be associated with our terminal velocity, and we'll look at equilibrium solutions in a minute, but let's just continue with the analytical solution. Okay, so if we assume this, we can get rid of the absolute value sign, and again, we're going to skip a step here because we've been through situations similar to this one. We're going to have 1 plus the square root of C over F times V divided by 1 minus the square root of C over F times V equals, I'm going to multiply through by the 1/2, or by the 2 to get an expression over here. And skipping steps, if we multiply this expression by 2 and then take e to this side equals e to this side, we're going to end up with e raised to the, let's be careful here, 2f over m times t plus c. Okay, now we have this equal to this, and we want to solve for our function v. I'm going to solve this equation for v. Now, that's going to be easy enough to do. The algebra is at this point going to become pretty straightforward. Going to multiply by the denominator, which will give us a v term over here and a term that doesn't involve v. Going to subtract that term from both sides to get all our v's on this side. We're going to move all constants over to this side, and then we're going to factor out the v and so forth. We've done something very similar already with the logistic equation and other examples that we've seen, so this should not be a big problem.